Hello, good evening, everyone. Can you hear me, guys?
Yes, ma'am. Good evening.
Yes, ma'am.
Yes, ma'am.
Oh,
Good evening.
okay. So in today's session, we are going to see like how to download the raw data from the NCBI, SRA, and the ENA browser. So all of you are like having the raw data in their system.
Yes.
Yes, ma'am.
Okay.
What about installation of cufflinks and cufflinks?
See, that part we'll discuss when the cufflinks session will be there. Or maybe in between we can fix that problem. Otherwise, we cannot proceed further with our data.
Okay.
Yeah, maybe you can see the recording. If you are able to do, then it's fine. Otherwise, just ping me. Okay.
Okay.
Yeah. Who's this? Well, Priyadarshini.
Yeah, yeah.
Okay. Just open the NCBI SRA. As we want to do the like analysis on the RNA-seq, so in the search box, you have to write your application name. Now you can see this many hits you are getting for this RNA-seq analysis. And if you want to download the data for a specific organism, so you can just select any organism from the top organism. And on the left hand side, you can see there are some filter they have provided. So let's understand what those filters are. First is the control access. Control access means whoever has submitted the data in the NCBI SRA, they don't want to share freely. So we have to ask the permission to download the data. Whereas in the public access, that is free, freely available. So you don't need to ask any permission there. Next is the source and the DNA. So currently we are working on the RNA-seq analysis. So that time you just have to select the filter as the RNA here. Then again, the hits will, yeah.
Yes, ma'am. Ma'am, what is SRA? As I am joining by now, so what I miss, can you please repeat that?
Ramandeep is one of the database from where we are downloading the raw data. Okay. Just
Okay.
understand, otherwise like you can refer the video. Okay. Next is the library layout. Again, you can see this is the single end and the paired end sequencing. It's up to you which type of data you want to work on. You can just select that. So for example, I want to work on single end. So these are some sequencing platform they have given here. And again, if you want to work on Illumina and Torrent, it's up to you on which type of sequencing platform you want to work on. You just select that. Again, the strategy for the RNA-seq, that would be the RNA-seq only. And the data, it is downloaded in the clouds. And also you can get different type of formats of the file here in the NCBI SRA. So as you are on the first page, I would suggest never try to download the data from the first page. Why? Because these are recently updated data, so there are some chances you may not get the complete information. So that is why always go with the older data. Maybe I will select this 2000 and just enter it. Now this is just a SRA report. Here you can see this is the SRA ID they have given along with the experiment name they are giving, and they have used the Illumina platform. How many spots they have used, the basis, and the size of the data. You can see it is in the MB. Then submission, it has been submitted by this research institute. All the run and the experiment they have given here, and in the abstract you can study all the abstract related to your experiment. So these are basic information they are giving you about your experiment. So as it is a single end, you can see here, if you want to download the single end data, you just have to go below.
Hello,
Hello.
ma'am, आवाज
Actually
नहीं
my
आ रही है।
screen is stuck.
Yes, ma'am.
Now can you hear me?
Yes, ma'am.
Okay. Now just select this run ID.
Hello. 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 Hello.
Hello.
Yeah, I think ma'am has network issue maybe.
Can someone please tell me that before SRA, if she like said or explained something, can someone please tell me?
No, she
Hello.
started with the SRA in this class.
Started now and she is not explained anything else.
Okay, okay, thanks.
Hello. Hello.
Yes, ma'am.
What yesterday? What you have taught actually? May I know that? Because I
Ma'am,
have joined today.
ma'am, no worries. Might be send your video.
In which email or something in which you will send?
WhatsApp, I think.
Okay, in which group which we have added all the videos is been sent in that only, no?
Yeah.
Okay, nothing any elsewhere.
Hello. Hello.
Yes, ma'am.
Please give somebody, please message her now.
Hello? Hello?
Yes, ma'am.
Hello,
Yes, ma'am.
yes, ma'am.
Yeah, sorry. Actually, I lost my connection. So now we are trying to understand how to download the data for the paired end, right? So this is for the paired end, right? Again, if I open this run ID and just go to the fast and fastq here, can you see there is no forward strand here and the reverse strand? Because in the paired end sequencing, you will get two files for the forward and the reverse. So this is the drawback in the NCBI SRA for the paired end sequencing. So if you want to select the paired end data, so what you can do, just select this ID from the NCBI SRA and move to ENA browser. And put this ID here. Same information you will get like the NCBI SRA, but here you can see for this _1. So _1 is what? The forward file, and _2 is your reverse file. So it is very difficult to separate from the NCBI SRA. So make sure whenever you are having the paired end data, so just simply copy the ID from the NCBI SRA and just put that in the ENA. You will get the two different files. Okay. But the data which I have shared with you, I've taken from this. So this is my ID and the title of my experiment. And later on at home, you can study this. I will just share this link with you. Then if you want to study more about this experiment, here in this abstract, you can read it. And again, you can see the data which I have chose, it has been taken from Illumina. And my data is the single end. So now what I did, if you have noticed in the raw data, you have two files for control and two files for treated, right? I will show you. Can you see this control one? So these four files you are having in the raw data, right? Everyone is
Yes,
having.
ma'am.
So I will tell you what is this control one, which the ID it is. So 12 runs, can you see that? And if I scroll this, can you see the control sample here? And this GSE1 is the treated. It's up to you which data you want to download, you can download. But I have taken this control one as this ID 458. 458, this is my control one. And this 459 is my control two. This I've taken. And for the treated one, I've taken this, and 453, this is my treated two. Now, along with that, you can see this is the treated one and treated two. and this is my control 1 and control 2. Okay, but the size of data is huge. Can you see that? So just for a demo purpose, so that like the pipeline can run easily in your system, what I did, I have just cut down the 50 lakhs reads from the data. So now I tell you from where I have taken this link. So if you want to download from this also, you can download from the NCBI SRA. But what I did, I just simply copy this, go to the ENA browser, put this ID. If you want to download the data very fast, so you can do it with the help of terminal also. So can you see this 452 ID? So just copy the link address from here. What you have to do, just type wget -c and paste that link. Okay. And how to download this from the terminal? You just have to simply copy this. Just open the WSL from here. So at the end, I will share this script also. So just make sure you just have to create the raw data and just paste this command and enter. So it will start downloading this particular data. Okay, 458. Okay, but for now I will just cancel this. Till here it is clear from where the data has been taken. Next thing is I have renamed this ID.
Ma'am, sorry for the interruption.
Yeah.
So for data downloading, we can use two methods. Either in the terminal, we can use the command, or we can download it from the ENA, right? That you showed.
Yes, ma'am. Actually, what happened? I have cut down the data for you guys, right? So it is very easy to download in your system, right? Can you see that I have shared the zip file?
Yes,
Right.
yes.
So, but in real time, if you try to download in your system, okay, with the help
Okay.
of the NCBI SRA or maybe the ENA browser, it will take lot of time. So in real time, if you want to download from the terminal so that easily it can be downloaded, you can just have to type simply wget -c and copy this link from the ENA browser. Okay.
Okay.
Yeah. Now you guys like are having these 4 files, right? Control 1, control 2. Now for this data, we have to check what the quality, right? Whether that data is good or not. So in the terminal, I will just write fastqc -help. So let's understand the commands. Now it is one of the high throughput sequence QC, quality control analysis tool. So you can see they have provided what the commands here. So you just have to call the fastqc tool, and after that you have to give your file name. Okay. So now what you have to do, everyone should open the notepad and just type this quality control. Okay. After that, how to run this fastqc? Just call the fastqc. Now, in the terminal, I will show you what are the files that are present in my raw data by doing ls. ls is just to list all the files that are present in the raw data. So you can see this are all my files, right? So either you write all the files name, just make sure the spelling would be same, then only it will run. So right now it's very easy because my files are only 4, right? But what if you are having the multiple files with the extension .fastq? That time it is very tough, right? For you also to write the multiple file name. So either you use this command or you run this command. So what is this? Just call the fastqc, and you can see this is the asterisk. Can you see this command asterisk? So it stands for all. So what it will do, it will check the quality for all the fastq file. Why I've written .fastq? Because you can see in all these 4 files, the common extension is this .fastq. Can you see that? So now what I will do, I will just simply copy this and just make sure you have to open the terminal from the raw data where your files are. Now run this command. Is it clear how to write this fastqc command?
Yes, ma'am.
So everyone can perform this fastqc in their system. So now we are checking the quality of your raw data. Should I share this command?
Yes, ma'am.
If somebody is stuck in between, just tell me.
Excuse me, ma'am.
Yeah, who's this?
Amit,
Yeah.
ma'am, for Ubuntu, how to perform?
Yeah, for the Ubuntu, can you see my screen?
Yes.
Okay. And also the one who is having the Mac can see the commands. Amit, can you share your screen? Actually, like in between, my screen is getting stuck.
Yes, ma'am.
Yeah. Meanwhile, others can perform the fastqc.
Done,
Who's this?
Priyadarshini.
Okay, Priyadarshini.
Analysis completed.
Okay, just wait. And after that, we'll discuss the output. Okay.
Okay.
Let others complete. Okay, nice, Shubham. Cancel this. Just open the Ubuntu. Amit, you haven't installed the WSL?
No, ma'am.
Okay.
Ma'am, I also not
The one who is having the Ubuntu can see the Amit screen. What you did, you tried to install the cufflinks, Amit.
Yeah. Yes, ma'am.
I
Yes,
guess
sir.
something is wrong in the bash rc file. Can you see
Yeah.
that error?
Yeah.
Yeah, so you need to fix that. You don't do anything to in the bash rc. I will fix that, otherwise it will create a problem for me.
Okay.
Okay, just wait. Now just write here cd space slash mnt slash c, enter. Now cd space users, enter. ls, enter. Now we have to check on which folder the desktop is there. Okay,
Oh.
because in the desktop you have this RNA-seq. Where you have created this?
Desktop.
Desktop. Okay, just check it one by one. Just write cd, then all users. What is your desktop name, Amit?
I think it's Renova technology.
Can you just copy that, Renuka technology? Yeah. And then run that command. ls. Can you see the desktop? Yeah, I can see. Just write cd. On the left hand side, you can see in below the cytoscape, there is a desktop option. Can you see that?
Yeah.
Yeah, copy that. Yeah, paste that now. Then enter. ls, enter. Just wait. What's your folder name? RNA-seq, right?
Yeah.
Yeah, I can see that. Just copy this. Now just type cd space RNA-seq. Enter. Now ls. Enter. Now cd. Because now you have to go inside this RNA-seq, right?
Yes.
Amit, you haven't extract this file folder, RNA data-seq.
No, ma'am. No.
Minimize this terminal. Open that. Yeah, I can see this is in the compressed format.
Yeah.
Select this. Do you have any? Yeah. Right click it. Can you see that extract?
Extract all.
Yeah. Extract. Make sure everyone is having the extracted file, because for the compressed file it will be difficult otherwise later on. So Amit, you have to follow same commands, okay, every
Yeah.
time to
Yes.
run on the Ubuntu.
Okay.
Now just open this raw data. Yeah, can you see this 4 files?
Yes.
Now you have to go inside this folder. Okay, now go back to the terminal. Yeah, now do it ls again. Yeah, can you see that now? RNA
Yes.
data human. Yeah,
Yes.
now you have to go inside that, right? Now just
Okay.
type cd space RNA-seq data human. Enter. ls. Now you have to go inside again to the raw data, right? cd
Okay.
space raw data. Enter. ls. Just run this fastqc now, that command which I've shared. Yeah. So it has started the analysis. Okay, can you see that? Now
Yes.
everyone can see this his Amit screen. Scroll up little bit. So these are some Linux command. So cd means to change the directory. So if you want to work inside the folder, okay, that time we are using the cd command, as he has written cd RNA-seq. Why? Because I want to go inside this RNA-seq, right? Just highlight that, Amit. No, below that. Yeah. Can you see that before this link that there is a desktop, right?
Yes.
Yeah. And after writing the cd RNA-seq, now it's went to RNA-seq folder. Can you see that?
Yes.
Yeah. Now, again, if I want to check what are my files that is present in the RNA-seq, I have written ls. ls is just to list all the files. Clear? cd and the ls command.
Yes.
So it is very useful in this bioinformatics. Okay. So just write somewhere this command, Amit, and
Yeah.
every time you have to run like this, each and every
Okay.
command. Okay. Yeah.
Okay.
Yeah.
Ma'am, I'm not followed you. Please,
Who's
can you please
this?
repeat? Even my Ubuntu I'm opening, it is not opening. The WSL I don't have.
Just share your screen.
Okay. Should I stop now?
Yeah.
Analysis is complete.
Okay. Just open, Amit, the files which you are getting. Sumalta will fix it later because we are hardly like left with 20 minutes and we have to complete this output.
Ma'am,
Because
which file?
just type here ls. So everyone can see his screen. Can you see for the control1.fastq, you are getting 2 files. that is the .html and .zip file. Can you see that?
Yes, yes.
Right? Now go inside your folder, Amit. No. Open the folder. Raw data folder. Yeah. Everyone is getting two files, zip and the HTML file.
Yes.
Others can
Yes,
respond who is having the analysis is done.
Yes, ma'am.
Yeah, HTML and zip. So
Yeah.
So what is this zip file? Zip file is containing the summary of the graphical representation, whereas the HTML file is what the graphical representation. So just open Amit control1.html file. Yeah.
This one, ma'am.
Yeah. Maximize this. Okay. So everyone open this control1 HTML file in their system. Now you can see on the left hand side some options they have given, right? So quality check has been done for the sequence, for the base, for the end content, for the adapters. Can you see that? The options?
Yes.
Right. Now can you see that tick with the green color? So that is indicating what? That parameter is having a good quality. Now, wherever you see the red cross mark, that thing is what the data is bad quality. And wherever you are getting this exclamatory sign, that is what the data is having the moderate quality. Got it? Clear?
Yes, sir.
Everyone?
yes, ma'am.
Clear.
Now, the important parameter in the QC is the per base sequence quality. You can write somewhere. In the QC, per base sequence quality is the important parameter. Then there is the over-represented sequence. Then last is the adapter content. So these are my three important parameter in the QC. So in this QC, if three parameter it is having the warning sign or maybe this exclamatory sign, so I cannot proceed further. Okay, so it should be in the green color. That is indicating my good quality. Now let's understand one by one this summary part. So first is the basic statistic. So here you can see they are giving you the file name. So file name for which the raw data you are checking the quality, that file name, can you see that? We are checking the quality for the control1.fastq, right? Next is the file type. So file type is actual base calling method they have used. So for each and every base, the quality is checked here in the QC. Next is the encoding. So encoding method is what? The conversion of the Fred quality score to the ASCII character. So you can see they have done either from the Sanger and the Lumina method. Next is the total sequence. Total sequence is the number of reads in our sample. That number they have mentioned. Next is the total basis. You can see the next sequence flagged as poor quality. Out of total reads, no read is having poor quality. That is why we are getting number as the 0 here. And now you can see the sequence length. So maximum read is having what? 75 to 150 base pair length. Okay, that is the sequence length. And percent GC, you can see that is the 51. So it's good, like it should be around 40 or maybe 260. So if it is between this, that time GC content is good. So basic statistic, it is clear. Now if you scroll down, go down. Yeah. per base sequence quality. So here we are checking the quality of each and every base. So as we have discussed in the basic statistics, what is my read length maximum? Amit, go up. 150, right? Go down now in the graph. Now can you see in the x-axis 150 here, right? So x-axis, it is indicating what the length of my one read here, okay? And whereas y-axis is indicating what? The Fred quality score, okay? Now can you see this blue color line? So blue color line means it is having the average quality score of the bases here. So it has been divided into three colors: green, orange, red. If my bases will fall here in the green, that time my quality of the data is good. And if bases are falling in the orange, that is indicating average quality. And if it is having in the red, that is the bad quality. So I will show you with the help of one diagram again. Just open the browser, Amit, and just type there fastqc. Yeah, open that first link. Go down. Go down. Just go down. Can you see on the right hand side? Yeah, just go down. Bad Illumina data. Can you see that? Example reports. Below that, there is a bad Illumina data. Yeah, just open that. Now I want to show you what is the bad Illumina data. So if, can you see that in the summary per base sequence quality, you're getting here the cross here, red cross. Why red cross? I will explain you with the help of diagram. Just go to this per base sequence quality. Yeah. Now can you see this yellow is indicating what? Bases. Okay. And this red line is what? The median value. Blue line is my mean value. And you can see all the bases are falling in the red color also and the orange color, right? Correct?
Yes.
So that is mean what? The my quality of the data is bad here, right? And also on the y-axis, you can see the below lines. Can you see they are falling in the below numbers here, 26, 24? Yeah. Yeah. Can you see these lines? Yeah. So they are falling below the 30 cutoff, right? So it is having what? The bad quality here. So if you got bad quality and good Illumina data, are you able to see the QC for the bad and the good? Clear?
Yes.
Now go back to our data. Not this, control one file, which you have opened before. Open it again, no worry, if you can't see. Go up. Yeah. So can somebody tell me what is the Fred quality score here for this graph?
46.
What, Mahalakshmi? What is the Fred quality?
36.
Could be 36. About
Over
36.
36.
Yeah. Above
It's
36.
over 36.
Yes,
Above
yes,
36.
right. Okay, so make sure the Fred quality score, the cutoff is what? Equal to greater than 30. Okay, so now we can assume here from the basis and from the Fred quality score, the quality of the sequence is good here. Okay, clear?
Yes, sir.
Now go down. Now it's like from this image you can see it's very clear. The sequence style is also good here. So sometime what you get, the different type of colors you are getting. So don't prefer that type of data. But if you are getting a whole graph with the blue color, that means it is having a good quality. Okay, go down. Next is the per sequence quality score. So here we are going to check the quality according to the read sequence. Just scroll down a little bit. Yeah. So x-axis here, it is what the Fred quality score. Okay. Now y-axis is indicating how read sequence are distributed overall. So now can you tell me our graph is taking peak at which number?
I think it's 36.
Yes. So maximum reads are taking a peak at 36, right? And also you can see the it is taking a little bit higher peak from the 34 as well, right? So none of the read, it is below the 30 cutoff here, right? So that means the quality of the sequence here is good because all the reads are more than 30 cutoff here. Clear? What is this per sequence quality score? Any doubt here in this? You can respond, guys.
No, ma'am.
No, ma'am.
Okay,
Clear,
fine.
ma'am.
Go down. Next is the per base sequence content. So here is what the how our different bases are distributed overall in the sample. Can you see all the bases are highlighted with different colors? Red, blue, green, right?
Yes.
Yeah. So now we are getting a random distribution. Where you are getting random distribution? Can anyone tell me?
At the
Ma'am.
beginning and at
Yeah.
the last.
Yes, correct, Jezreel. So at the beginning, you can see this is a random distribution. Can you see that 1 to maybe 15? Can you just highlight, Amit? Yeah. No. Below, from the below axis, x-axis. Yeah. From.
No.
Okay,
It's
don't
not.
worry.
No.
Okay, now everyone can see the random distribution at the beginning and at the end, right? So what are this random distribution, Jezreel? Why we are getting this type of data here?
I didn't hear you clearly.
What?
I didn't hear you clearly. I didn't hear what you ask.
Okay. So this random distribution is basically due to some error or maybe some biasness in your data. That is why this type of data you are getting. But also from 15 till 139, you are getting a parallel lines, right?
Yes.
Yes. So that particular part is good here. Okay.
Yes.
But maximum you are getting the random distribution. That is why here you are getting a red cross in the per base sequence content.
Yes.
Yeah. Now go down, Amit. Next is the per sequence GC content. Now, can somebody tell me what is this? Why
Sorry
we are
to, sorry to interrupt.
checking the GC content?
Sorry, may I ask you a question about the power base sequence content?
Whoever it is, like, can we have
Rabbani.
these queries after the session maybe?
All right.
Just let me complete and then we'll solve that queries, okay? Just let me complete. So now what is this GC content? Why they are checking the GC content? What is the role?
Adapter binding and something like that. Like,
What is this GC?
I think it's okay. This
Guanine and sets.
guanine
What?
site, yeah.
What, Shubham?
Guanine and
Guanine and
cytosine.
cytosine content.
Yeah, guanine and cytosine, right?
Cytosine content.
Yeah. So,
Temperature wise,
I
I
think
think
it's
so.
necessary for annealing of adapter and primer like.
Okay. So we'll see how GC content is distributed in our sample here. So why we are checking? Because GC content is showing the stability in our sample. So you already know GC is connected with the 3 hydrogen bonds, right? So that is why it is giving a stability, right? So that is why they are checking the GC content here in this. So now here, just wait. Can you see the peak of the GC content?
Yes.
So what is the number for the GC content here? So every, like each and every read, it is taking a peak at 51 here, right?
Hmm.
And also blue color line, can you see that?
Yes.
So this is not for our sample. Red is for our sample. Okay. So whenever our sample is just like the bell form shaped, that means the GC content is good. Okay. So still at the top, you can see it is having some not the clear peak here, right? At the top. Can you see? It is not just attached to the bell formed there. So that is why they are giving you the warning here. Clear? So it should have less difference between the lines. Clear about this, GC?
Yes, ma'am.
Now go down.
Yes.
What is the N content? Can anyone tell me? If you know.
Right.
What, Shubham?
Ma'am, it is, I
Space
think,
like
nitrogen.
something missing and
Nitrogenous
Number
bases.
nucleotide.
It's a nitrogenous base.
Bases which are not correctly called by sequences.
adenine and purine like.
It is not detected by the sequencing machine. Hello?
Yes,
Hello?
ma'am.
Ma'am left maybe.
Hello? Hello?
I think ma'am disconnected again.
Okay. Hello, ma'am. We are unable to hear you.
She's not here. She's off the grid.
Ma'am has left the meeting, I think, because she's not in the participant list. Maybe she has some network issue.
Yes, I think so.
Hello.
Yes, ma'am.
Yeah, sorry guys. I don't know what's the issue with my network today. Okay, just go down to the sequence length distribution. Yeah.
Ma'am, we will start from per base n content. From there,
Okay,
you were not
okay.
there.
Go up. So yeah, it's nothing here in this graph. N content you can see it will be indicated with the red color, and on the x-axis you can see just nearly to 0 here. Can you see that? That means N content is not there in your raw data. Okay, for the control 1 file. Now go down. Next is the sequence length distribution. So in this basic statistics, like we have already discussed, most of the sequence will have what length?
And what is per base and content?
What length? Amit, go to basic statistics. Yeah. Now, what would be the length for the sequence? 150.
75 to 150.
25 to
Yeah,
150.
yeah. Now go down to the sequence length distribution. Now, not this. Go down. Yeah. Now, same thing it is giving you here also. Maximum length of the sequence, it is falling after the 145. Can you see that? Right. Now go down. Next is the sequence duplication level. Okay. Now, can you tell me what is the sequence duplication level?
Sometimes the
Sequence is
machine detect the
duplicated, I
sequence,
think.
read the sequence 2 times. Like
Okay.
Means sequence is duplicated.
Yeah, correct. So reason for duplication is that is the amplification. The main reason is that amplification. So during library preparation, we are doing the random fragmentation, right? So there we are providing the adapters for the amplification. So due to over amplification, there are some chances we can get the duplicated data in our sequence. So that is why what it is duplication. Clear? What is the duplicated sequence? And also I will tell you, if you want to read more about this section for the fastqc, Amit, go to the browser and open fastqc again. Open the first link. Go down. Can you see that copy of fastqc? Just select that. And there is a third folder, analysis module. Now one by one you can open, for example, per base sequence quality. Second. Open this. Now every information they are mentioning it, just go down. So at home, like if you want to read more about this QC, you just open this analysis module, you will get each information for each section. Clear, guys?
Yes.
Okay. Now go back to the control 1. Yeah. Now can you open this overrepresented sequence? That is important. Now, can you see this green color? So here you can see this, there is no repeated sequence, and also there is no adapter, right? So now I will tell you how it look like in the bad Illumina data. Just go back to the bad Illumina data. From up, you can see here the page is opened. Next to that. Next to that, yeah, Sanjana, it will be provided. Just go to the bad Illumina data. Go to overrepresented sequence. Yeah. Now, can you see they have provided sequence and the count and the percentage and the no hit, right? So it's fine for all those sequence. Now go down. Go down. Yeah, wait. Just go up a little bit. Yeah, instead of no hit, can you see that Illumina paired end PCR primer? So this is what the primer sequence. Okay, so sometime if you get this type of data, that means that particular sequence should be removed from your data. Okay, because we are not interested with that sequence. So that particular sequence, can you just highlight that sequence? No, not this whole, only sequence part, Amit.
This one.
Yes. So that sequence we are going to remove with the help of the trimming tool, that is the cutter depth, maybe fast P, or you can use the trimometric, trim galore. So there are a lot of tools. It's up to you guys, like which tool you want to work on. So you should know how to run those tools. That's very important. Okay. So is it clear like how the adapter sequence they are looking?
Yes, sir.
Clear?
Yes.
Okay, fine. Go back to your control 1 file. Adapter content. Yeah. Now again, like you can see here, if you are not having any overrepresented sequence, so automatically, like you can see in this graph also, there is no adapter. Can you see there are a lot of adapters that are highlighted with different colors? Illumina universal adapters, this many, right? So again, it is nearly to 0 here in your data, right? So that means the data which you have downloaded, so that data is good. So we don't need to perform the cut adapt for your data. Clear, guys? fastqc. And
Yes, sir.
make sure if you want to like study more about this QC, I have already discuss like the copy from where you have to get that information. Just check it once. And so we are ending with the QC here. Okay, and the next step we will perform tomorrow. Okay,
Ma'am,
Okay.
so that means for checking the quality, we have to just check mainly the three. That means the per base
yes
sequence
ma'am.
quality, the green tick will be there, then we can proceed. And if there is
Yes
red tick,
ma'am.
we have to go for the trimming, right?
Yes ma'am, just make sure the per base sequence quality, just highlight. Yeah, this one should be green color. Then
Yeah.
overrepresented sequence, sometime you are
Yes.
getting exclamatory here. So exclamatory is indicating some of the sequence are having the adapter sequence. So that particular sequence you have to remove with the help of cut adapt, ma'am. Okay, so your data is good, but I will tell you how to run the command for the cut adapt. So that time in future, if you are getting the bad data, so you should know how to remove that sequence. Okay, so I will give you the commands tomorrow. Clear?
Okay, ma'am.
Yeah. So we'll end here. Anybody else who is having doubt in the installation part?
Yes, ma'am.
Who is it? Like who? Sumalta.
I'm Sumalata. Yes.
Anybody else?
So can we leave if we don't have?
Yeah. People, yeah. So
and ma'am, tomorrow which topic you will teach us? The
ma'am,
trimming part.
we'll discuss not in detail the trimming part. I will discuss only the command for the cut adapt, because in future you might get the adapter sequence, right? So we'll discuss how to see the commands for the cut adapt, and we'll perform the mapping part further.
Okay. Thank you.
And make sure you guys are having HISAT 2 tomorrow. Okay. Okay, then you can leave.
But is there any means of